The planet Arrakis, colloquially known as Dune, serves as the prime setting for the 1965 science fiction novel of the same name, written by Frank Herbert. Additionally, it features prominently in all 5 sequel novels, numerous prequel novels, and several film and video game adaptations. Being among the first exoplanets to be depicted in science fiction, Arrakis would go on to inspire countless other similar worlds throughout the science fiction spectrum, spanning all the way up to our modern time. Unfortunately, the novels offer little physical information about the planet, and what is said is often quite vague and insufficient for scientific analysis. But 1984 saw the publication of the Dune Encyclopedia, which sought to address many of these unknowns. Although the book was a composite work by several authors, Frank Herbert authorized its inclusion into Dune canon, saying in the book's foreword that he gives the encyclopedia his, quote, delighted approval. Therefore, the scientific analysis to follow is based predominantly on the information presented within the encyclopedia. The planet of Arrakis is a dry terrestrial possessing no recorded surface water. Instead, its surface is blanketed entirely in deep quartz and feldspar sand ergs, drowning all but the tallest mountain ranges. It has a reported radius 4% smaller than Earth's, a mean density of 4.95 grams per cubic centimeter, and a surface gravity of 0.88 g. This gives it a calculated mass of somewhere around 0.8 Earth masses. Arrakis's atmospheric composition and pressure are similar to Earth's, being 74.3% nitrogen, 23.6% oxygen, and 1% argon at 101 kilopascals of pressure. Water vapor makes up an additional 0.5%, as does ozone, with carbon dioxide comprising 0.035% of the atmosphere, which is slightly lower than on Earth. Arrakis is the third planet of 6 orbiting the star Canopus, which is a real star lying approximately 310 light-years from Sol, in the direction of the constellation Carina. Although the Dune Encyclopedia lists Canopus as a main sequence star, Canopus actually left the main sequence millions of years ago and has since expanded through its red giant phase and into what is known as the blue loop phase. It now exists as a spectral type A92 white giant star. According to Dune canon, Canopus has a binary companion in the form of a Jupiter-mass white hole in a very tight orbit that constantly streams material onto the star's photosphere. Arrakis revolves around both of these objects in a P-type circumbinary orbit at a distance of 0.58 astronomical units. Due to the gravitational influence of its 2 neighboring planets, Minaris and Extaris, Arrakis is reported to have a fluctuating eccentricity that results in a variable orbital period, ranging from 295 to 595 days, with its year length being approximately 353 days during the events of the story. These interactions are also said to give Arrakis a variable rotation period, which at the time of the story's taking place is reported to be 22.4 hours long. Arrakis is orbited by 2 major moons, Arvon and Creon. Arvon is the innermost moon and is the smallest of the 2, orbiting at 0.27 lunar distances with a period of 5.7 days. Creon, the larger outermost moon, orbits at 0.84 lunar distances with a period of 25.2 days. Both moons occupy the same orbital plane, and thus eclipses of the outermost moon take place on average every 547.2 days, with Arvon completely obscuring the disk of Creon due to its closer proximity. It is believed that a third natural satellite once existed around Arrakis, but geological evidence suggests that it was destroyed by a cometary impact 200,000 years prior to the events of the books. So how does Arrakis measure up scientifically? Since Arrakis's mass is never stated, we are forced to derive it from other parameters given in the Dune Encyclopedia. The problem is, none of these methods agree with one another. If we derive Arrakis's mass from its surface gravity, we get a value of 0.8145 Earth masses. But if we instead derive its mass from its mean density, we get a value of 0.799 Earth masses. If we derive its mass from the orbit of its innermost moon, we get a value of just 0.4462 Earth masses, while the orbit of its outermost moon gives us a value of 0.6942 Earth masses. In an attempt to make some sense out of this mess, I have chosen to disregard the values given by the orbits of its moons because, as you will see a bit later, Arrakis' satellites are a disaster unto themselves. This leaves only the values given by its surface gravity and mean density, which differ by less than 2%. So I feel that the average of these two values represents the most likely mass of Arrakis, and their disagreement can reasonably be labeled as a rounding error. Given these concessions, I will begrudgingly award the planet's geophysical realism a score of +1. Arrakis' neighboring planets are said to pass very close to Arrakis in their orbits and gravitationally tug on the planet, keeping its orbit eccentric and resulting in it having a variable orbital period. Not only is this an unstable system that would likely have catastrophic results over geological timescales, but changes to eccentricity like these could not alter the length of a year to the extent stated. A few days to a week? Maybe. But 300 days? No. Making this even more absurd, based on Arrakis' stated orbital distance and the mass of its parent star, it should have an orbital period of less than 60 days. Similarly, tidal interactions with its neighboring planets could potentially cause Arrakis' rotation rate to fluctuate, but again, not to the extent stated. And these interactions would have the side effect of destabilizing the orbits of Arrakis' moons and ejecting them from planetary orbit, or worse, crash them into the planet. -1 point. Arrakis is far too hot to be habitable, given its proximity to Canopus. But ignoring that for a moment, it also could not be a desert planet given how much water is reported to be in its atmosphere. One can imagine that during the heat of the day, its water remains aloft in a vapor form, but eventually it would cool, condense, and rain out, either as a result of nightfall or convection carrying the warm, humid air to higher latitudes. If water can condense onto a mouse's ears, it will certainly condense onto cold stones, leading to runoff that forms streams, rivers, lakes, and possibly even oceans. Of course, true desert regions could exist on Arrakis, particularly at mid-latitudes where the air has been depleted of its moisture, but they cannot cover the entire planet. -1 point. Nearly everything about Arrakis' moons is inaccurate. First, given the dynamic nature of how terrestrial moons are formed, it is nearly impossible that Arrakis could form two major moons, much less the three it is said to have once possessed. The moons are also reported to have little to no eccentricity in their orbits, which is impossible given their method of formation and their close proximity to one another. Additionally, the orbits of Arrakis' moons are not mathematically correct, and should instead have periods of 2.87 and 15.75 days, respectively. Lastly, the innermost moon, Arvan, has a mean density that suggests a significant portion of its mass is in the form of water ice. This is common for moons around gas giants that, like those in our solar system, dwell out beyond the system's frost line, where ices are stable. But such a high ice content isn't possible for a moon around a planet in the habitable zone, as the stellar radiation is too high for ice to exist. It's possible that Arvan could have some water ice trapped in pockets beneath its crust, but this would not be enough to lower its mean density to the extent stated. -1 point. Canopus was a terrible, absolutely awful star to place Arrakis around. Having left the main sequence to become a late-stage star, it has swelled to over 73 times the size of our Sun and reached a luminosity 10,700 times greater. This means that the amount of energy Arrakis receives from Canopus is over 39,000 times greater than what Earth receives. Arrakis wouldn't be hot. Arrakis would have evaporated long ago. Throw on top of that its impossible white hole companion, and its stellar realism obviously receives a score of -1 point. With a total score of -3 points, the planet Arrakis from Dune receives a dismal grade of F3. I'm sure that the authors of the Dune Encyclopedia had the best of intentions and tried to make the astronomy of Dune as intricate and novel as its cultural and political landscape. But they tried too hard, letting their ambition outpace their abilities, and like Icarus, they flew far too close to a very hot sun. Thank you for joining me on this analysis of the planet Arrakis from Dune. From here, I'll be leaving the Canopus system behind and charting a course for another fantastic alien world. I hope to see you there.